G'day YouTube, JB from Oz here. So tonight we have the Diplomatico,
if you don't have a little bit of radius
cane on the tube,
and you examine your cut very
and a set of drawings,
glass, you're going to see
and a part
in effect you have produced an extreme
that we're currently going to have a bit of a beat up on.
So just a little bit of a radius
So
in there, and
this, believe it or not, is a project that's sat in the workshop. Well, you can probably guess with all the dust that's there. Sorry, Turbo Cane. Here's a project that's sat in the workshop for probably a year, maybe even 2 years. Ben, how long has it been? This is from my brother. Essentially the goal of this one is to take his coffee making to the next level. There is a steam pressure and there is a coffee pressure, or temperature rather, steam temperature and an espresso temperature, such that the coffee beans are held at precisely the right temperature for the expression of the coffee out of the beans. So, rather than relying on Gaggia, Classic Gaggia, to know what the hell they're doing, we are now going to assist with the implementation of this secondary thermocouple. Where's the thermocouple? Ah, downside. Downside we have a thermocouple which will be used in conjunction with the PID controller to assess the temperature of the water inside the boiler using this solid state relay to engage and disengage the heater to the boiler, such that the temperature in the boiler when we are about to express our espresso is the correct temperature, and subsequent extrusion of the coffee can happen appropriately. Thank you very much. Alright, now we're coming to the meat and the potatoes of this particular assemblage. We've got a certain distance down the track with this old assembly prior wise. However, this time we need to go to one step further. The issue at hand is that there's correct wiring and incorrect wiring of this switch. Potentially we should remove all of the wiring that has been added. In fact, yes, let's do that. Take us back to a neutral position and then expand from there. That is potentially the best way forward. Always hard when working on somebody else's determination to understand exactly what they have achieved so far. Too many wires, too many buttons. Can't be asked. The point that we got to was that the pre-existing circuitry needed to switch on, provide power to our PID, express a toggle to steam which triggers which of the sensors we are using to control temperature, and essentially cuts out the PID circuit entirely, and then the operate for that particular function. So where we got to is the internals of this switch was not making sense to me, and I asked my brother to see if he had a better diagram of where the back face of this switch was actually driven from. So potentially what we do is we plug it back in and see where we're at. Let's double check some wiring first. Okay, we have our K-type thermocouple wired up to our Burme Rex C100. Rex C100 says instrument power, noise filter, power terminal, shortest distance, noise filters. I'm not going to worry about any of that crap. Alright, so we've got circuit tray on the side. Have we got SSR is 4 and 5. Where are our labels? numberage. Nah, I can't see this small. Do we assume, gentleworms and ladies, 1 and 2, 3, 4 and 5 is the SSR. Okay, why is 3 connected to there? RT, thermocouple, alarm. Why have we got this green wire connected through? Previous instructions of somebody with an instruction guide says something. Temperature. Thermocouple, RTD sensor, jumper cable. SSR, 2 red colour thick cables should connect to terminal subject 1, doesn't matter which of the cables, yada yada yada. Yada yada yada. Blue cable, RTD sensor. One is to the hot wire, the other is to neutral wire where the power enters the machine. Ah, there we go. We have a hot wire. Oh, they're calling that neutral. No way. What? Brown is neutral, that's the hot wire. What are we going on here, Paul? So, the supply is tapped from the hot, which comes from the blackening, which goes through a thermal fuse to neutral. Okay. Alright, so in a sense, can you see me there, people? Yeah, alright. We have power to the temperature controller, appearing to this, AC power, brown and blue. Alright, so when we are off, when we are on. What? There's an illumination LED. The illumination LED is only going to come on blue, connected to pin 1, 2, this is the problem. With predefined wiring. 864212. All right. 7P. So 2 copies the same wiring. We take this out of the circuit, because I think that is part of the problem, is this is presently in the circuit. Put that off to one side. Green, 3, neutral. I don't know. I don't know why we've got an earth on that bloody relay. But what we do have is a loose earth. Fuse is to black. I don't like it when numbers are bad. It's not number 9, it's number 7. Okay, looking through from the front appears to be how we've got this wired up. Blue, grey, got 2 poles of the heater. Neutral, grey. Okay. 1, 2, 3, 4. Grey. Green, white, white. Blue. Sensor switch. Blue. Blue. Green feed blue. black, blue and black. So the black is going to go to the bottom. That blue is going to go to the bottom of that. Then this one is going to go red. And red. Does the white go? Power. So, switch 4, it's got white and blue going to it. So that becomes the thermocouple switch, which is those two. So then our grey, which is coming from another grey, which is currently connecting power. That should be coming into there. So this grey should be coming off the bottom of that and the heater, which then just leaves our power and our return to be wired in. So we know our blue is our blue. And our neutral, so brown through a fuse to a black. The black comes out to there. Because, of course, for the light to illuminate, we still need a neutral, I believe. So, shall we test the logic? Let's test the logic. Let's go with a beep. Okay, we are off position. We don't expect there to be a connection between here, between here and here, but we do expect one there. Okay, do we expect one here? No, but we do expect an ohmage between there and there. Alright. Don't know about the globage, but what we know critically is that it's not going to short, is it? So no matter which position of those two goes, we don't have a short. Between these two, that's power on. And power on, we expect to have power to one side of that. Now, we expect to have power to one side of the pump, one side of that connect? Not that way. That way it does. So the white has power. And the blue So the white has power in one way, and then the red has power in the other way. So white connected to neutral in one way. Mains blue to the top, also to that, blue to the black. So in one case we've got power automatically, the other side we've got to wait for that to join. What do you say, peeps? Do we see if we blow it up? Let's see if we can blow it up. everything's off. How come that has power if everything's off? Brown, it's black, blue, just blue. Okay. We don't want that. We want our switch to be triggered so our switch side wants to be switched into our supply to the unit. And our supply side wants to be isolated by the on-off switch. So, the only way we get power to the PCD is if we have power to the unit. Now, theoretically, when we connect that, we should have a connection to that, to the neutral, and also the globe. That connects through to our supply via thermal fuse. Look, let's see where we go. Nothing is on. Hey, check it. Now, we see temperature rising. What happens if we switch that? Still rising. Hey, we got it. So, we're heating to 150 presently. So the 150 is going to be PID control. Can we see that? Yep. 150 is going to be a PID control. We have mains power. We have a switch here. I'm not quite sure what's going on there. Maybe one is the steam control. Temperature sense. I wonder if steam is different from the other one. So essentially what we'll end up with, this should level out at 150. If it holds its temp at 150, we will then change to steam mode. We should see the temperature change on this readout based on the temperature of the steam sensor, which will be a different value. So the PID controller on the temperature is currently getting us up to 150. Alright, now we're going to change to steam mode, which I expect to be a different temperature. So the temperature is dropping even though the PID controller is saying to increase temperature. My guess will be that this will become the steam temperature. Right, well, I'm going to call that good enough for my brother to have a play with. Thank you for watching. Here's how to hack a Classic Gaggia coffee machine to accept PID temperature control on the coffee temperature. Job done.